Everyone out there knows that plastic is in our everyday lives. We wear it, we package in it, we buy, we shop, we drive in it, you name it. Plastic is everywhere. But when I look out at the ocean and I collect a liter of water and I find particles of plastic in every single liter that I look at, I start to worry. In fact, in the Strait of Georgia, we have over 3,000 particles per cubic meter of seawater on average. 3,000 particles.
At the Ocean Research Pollution Program, Dr. Ross and his team are trying to gain insight into microplastic pollution in our oceans.
We're concerned about microplastic pollution because there exists the potential for these tiny particles of plastic to be taken up by zooplankton, baby fish, big fish, seabirds, marine mammals, humans, all sorts of species that rely on the marine environment, on a healthy ocean.
It's painstaking work. Various samples like shellfish, mud, or water are broken down or cleaned up, filtered, and then placed under a microscope. Each particle is methodically counted and characterized. Forensic technology is being used to identify the source of the pollution. A spectrometer narrows down the exact polymer of each tiny particle of microplastic and cross-references it with a global database. It isn't just the scientific community interested in this research. Outdoor retailer MEC has signed on as a partner.
We are bringing a lot of different stakeholders to the table. All together, we can really look at what that source map is and provide context, and then that really enables solution-oriented decisions.
Metro Vancouver is also collaborating and providing information about how these microplastics might be getting into our oceans.
The Vancouver Aquarium sort of brought together the different partners. It's allowing us to address the problem more fully or more holistically. We're looking not only at what's happening in the treatment plant or what's happening upstream before it gets to the wastewater treatment plant. We're looking at what happens in your home, how it travels through the wastewater treatment plant into the environment, and what happens in the environment.
Your washing machine may be a key source for this pollution, and many loads of laundry are being done at the Anasys Research Center in an effort to understand this better.
What we're trying to do is quantify the impact from different types of materials. So like depending on what it's made of, is it polyester acrylic, or what the type of weave is, how much does that fiber or that textile shed fibers?
So it affects all textiles, whether you're looking at cotton fiber, whether you're looking at synthetic fiber, whether you're looking at fleece or yoga pant. These are all going to be shedding. That's part of what we need to look at, is how do those then end up in the ocean environment? How do these degrade and break down? One of the key elements that we're hoping to inform is a rapid assessment protocol for industry. This is what we're looking for in terms of material, and really drive that prevention of microfibers right from construction through to product.
I haven't encountered in my career such an appetite for scientific information and for answers that lead to solutions as I have with the microplastic problem. And what this provides me with is a sense of optimism that what we can do is deliver good science that people can then turn around and use to affect positive change. Changing the way that we create clothing, or whether it means the way in which we dispose of products after their life is over, or recycle, or whether it means we're using wastewater treatment plants to do triage and to separate out and prevent the release of microplastic particles. All of these represent opportunities to us.